Alright, and welcome to Permutations and Combinations Level 4. So we have a 5-person committee will be selected from 9 individuals. How many ways could the committee be chosen? Well, the question we want to ask ourselves here is first, does order matter? And in this case, when you take a look at this, we see, hey, we have a 5-person committee. It doesn't give us any details. We're not saying that someone's being chosen for president or someone's being chosen for vice president. There's no different value, you could say, per person. All 5 people in the committee are going to be equal. So if you get chosen for the committee, one spot is not better than the other. So we would say that there's no value difference, and therefore the order does not matter. Well, when order doesn't matter, we are going to use combinations. So think back to our last example, or our last level. When order does matter, we use permutations, but here we're going to be using combinations. So what is the combination formula? It is simply n factorial over n minus r in parentheses factorial, and then you add on an additional r factorial. This little r factorial on the bottom is the only difference. So let's go ahead and start plugging things in and see what we can do with this. So on the top we have n factorial, and what is the total number of objects in this set, or how many people are we choosing from? And we see that here we are choosing from 9 individuals. So we're going to write 9 factorial over, and here on the bottom we have n again, 9 minus, and then the question becomes, how many people are we choosing? How many objects are being chosen from this set? And since it's a 5-person committee, we'll do 9 minus 5 factorial, and then we're also going to put in 5 for this remaining r factorial. So let's go ahead and see what this looks like in practice. We now have 9 factorial over 9 minus 5, which is 4 factorial over 5 factorial. And what we want to do here is we always want to cancel out the largest factorial that we can. So on top, I'll write 9 times 8 times 7 times 6 times 5 factorial. Of course, we could have gone down to 4 factorial, but that would be kind of silly. So we cancel those two things out. And so how are we going to write this out? Well, we now have 9 times 8 times 7 times 6 all over 4 times 3 times 2 times 1. Because remember, 4 factorial has to be written out. Now let's go ahead, let me pull up my calculator, because we're definitely going to need our calculator for this top portion. And ask yourself, what is 9 times 8 times 7 times 6? And that will give us 3,024 over, and on the bottom we have 4 times 3, which is 12, times 2, which is 24, times 1, which is 24. So, what is 3,024 divided by 24? And it turns out there are 126 different ways we could choose 5 people to be on a committee out of 9 individuals. Go ahead, pause this video, and finish taking your notes, and we're going to go ahead and move on to our second example. Alright, here we have our second example, and Mr. Martinez has 24 students. In how many ways can he sit them? Oh my gosh, how many ways can he seat them in groups of 6? Well, the question becomes, does order matter? And when we look at these groups of 6, is any one position in these groups better than the other? Or is any group better than the other? And the answer is no. And since there's no value difference, we're simply going to say, okay, we're going to use a combination, which is n factorial over n minus r factorial r factorial. Okay, and let's see, what's the total number of students that we are choosing from? We see it is 24. So we'll write 24 factorial over parentheses. And once again, we have n on top, n on bottom, so we just write 24 again, minus r, the number of objects being chosen. And in this case, it would be 6. So we write factorial there. And remember, for combinations, we have to add an additional our factorial. Now, what would this simplify to? Well, it would become 24 factorial over, and what is 24 minus 6? Well, that would give us 18 factorial, 6 factorial. And so in this case, we want to get rid of the largest factorial possible, so I could write it as 24 times 23 times 22 times 21 times 20. I'm really having to squeeze here. Times 19 times 18 factorial. And all that is a weird division sign. All over 18 factorial, 6 factorial. So these 18 factorials cancel out. And let's go ahead. I'm going to grab my calculator. And here's what I'll do. On the very top, over here where we have 6 factorial, I'll even write that out as 6 times 5 times 4 times 3 times 2 times 1. Well, let's start multiplying these numbers together. So 24 times 23 times 22 times 21 times 20 times 19 times 18. And that's going to give us an incredibly large number. That will give us 1,744,364,160 all over. And of course, we have 6 times 5 times 4 times 3 times 2 times 1, which will be 720. And once we divide these two numbers, we'll have our final answer. Let's try that. 1,744,364,160 divided by 720, which will give us our final answer of 2,422,728. And there are this many different ways, 2,422,728 different ways Mr. Martinez could order 24 students in different groups of 6. Alright, I hope this helped, and